Okay, for next question, it's given that a vehicle of mass 30 quintals moving with a speed of 80 kilometer per hour collides with another vehicle of mass 90 quintals. So uh, let this be vehicle 1 and its initial velocity is 18 kilometer per hour and it has mass which is 30 quintal and it collides with another body of mass 90 quintal and its initial velocity is u2 is 14.4 kilometer per hour. Okay. And it's moving in the opposite direction. So this is the direction. So we are going to take this as a negative. And let me just take this off. So it's moving in the opposite direction and the mass is 90 quintals. Now they both collide and we have to find the velocity of each after collision. So let's say both these collide and the collision be perfectly elastic because it's not given in the question the type of collision. So we are going to assume this to be the perfectly elastic collision. Okay, so after collision, let's say they collide and let's say V1 is the velocity of the first body and V2 is the velocity of the second body, mass being the same, and we have to find the velocity of each. That is, we have to find the final velocity of both the bodies, V1 and V2. So let's first use according to law of conservation of momentum B because we have two variables. So we will try to make two equations according to law of conservation of momentum. We know that according to law of conservation of momentum, initial momentum is equal to final momentum. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay, m1 is 30 and its initial velocity is 18 kilometer per hour. M2 is 90 quintals and U2 is 14.4. It's again 30 and 90 and V2. Okay, so we have this equation that we have the first set of equation. We have got our first set of equation and let's try to find out the second set of equation. So, okay, so 30 into 18 is 540 and this is in the opposite direction, so it's negative, so negative and 9 fours are is 36, 9 4 36 and 3 39. So 1296 is equal to 30 V1 plus 90 V2. And so this is negative 1296 minus 540. So if we subtract this, so this is equal to negative 6, 5 and negative 756. If we take 30 common here, so this is V1 plus 3V2. Okay, so this finally we have this equation V1 plus 3V2 is equal to negative 756 divided by 30, which gives me 3 2s are 6, 3 5s are 15, 2. So this is equal to negative 25.2. And we have our first set of equation that is V1 plus 3V2. So this is V1 plus 3V2 is equal to negative 25.2. This is the first set of equation. And to get the second set of equation, let's consider this collision to be perfectly elastic. And we know that for perfectly elastic collision, coefficient of restitution is 1. So for perfectly elastic collision, coefficient of restitution is equal to 1. And coefficient of restitution is given by the velocity of separation, that is V2 minus V1, the initial velocity of separation upon the velocity of approach So V2 minus V1, and U1 is 18, U2 is negative 14.4 is equal to 1. So finally we have V2 minus V1 is equal to 18 plus 4, 14.4 is 8, 4, 8 plus 4 is 12. So this is 32.4. This is our second set of equation. So we have got our second set of equation, and let's try to solve these two sets of equation to get the final velocities of the two bodies. So the second set of equation is V2 minus V1 is equal to 32.4. So I'm going to write down these two equations, V1 plus 3V2 equal to negative 25.2. And the second equation is negative V1 plus V2, which is equal to 36.4. And if we add these two equations, so 3V2 plus V2 is 4V2, and this is 32.4 divided by 25.24. 12 minus 5 is 7. So this is 7.2, which gives us V2 is equal to 7.2 divided by 4. So final velocity of the second body is 1.8 kilometer per hour. And we can use either of these equations. Let's use the second equation to get uh, the final velocity of the first body. So this is 1.8 minus V1 is equal to 32.4. So this is negative V1 is equal to 32.4 minus 1.8. So V1 is equal to 32.4 minus 1.8 is 6. So this is 30.6. So 30.6 kilometer per hour. And V1 gives me negative. This is 30.6 kilometer per hour. That is, uh, the direction of V1 is towards the left hand side, as indicated by the negative sign in this value. So we have got the final velocities of A and B, that is 30.6 kilometer per hour and 1.8 kilometer per hour are the final velocities. And this body, the first body, this will go in this direction.